GAC, what is up? It's Coach Jay in the house. Hope you're having a great night tonight. I hope the first few problems were of help to you as many of you dominated them for the test. And so I really appreciate that. Thank you so much for your consistency. And I just say keep it up. Keep up the good work. All right. I know some of you are watching right now, and some of you are coming late because I sent it out late. I apologize for that. It's what happens when your daughter wants you to put her to bed at night. So just a little bit. But regardless, we're going to get it rolling. We're going to get the questions answered. The first 5 minutes are key, so I would like to start there. And if you have any other questions, feel free to address it. And we'll get it and go from there. Okay? All right, so without further ado, all right, let's get started. All right, the one problem that I wanted to hit on tonight that many of you, I hope everyone is on for this one, is this idea of summation. Now, when we talk about summation, the summation formula, we did one today in class where I had to sum up the following. I think this was like 10 up here, and this was n equals 1. And it was like 2, negative 1/2 to the n minus 1, right? And I said use the geometric sum, or I just said simply sum this. Well, since we knew it was geometric, we knew a sub 1, or the first term is 2. We knew r was negative 1/2. And we knew because of the fact that this was had a power within it and followed the geometric nth term, we said that this was geometric, and the fact that this was a sum. So at this spot, since it went to 10, we recognized that 1 to 10, there were 10 numbers that we were summing. Therefore, 10 was n there. And then we simply plugged it into our finite geometric formula, which many of you had no problems with. And then we plug it in and go from there. The only thing that I would say, make sure that you do r to the n power first. Now, all of this is true. Okay, everything that we talked about is completely true. But what I'd like to do is just look at number 14, because this one will be on the test and is one that I want to make sure that we address before the night is through. So I want to start with this one mainly because some of you may not watch the whole thing, which is okay. But I do want to make sure that many of you, if not all of you, watch this number 14. Now, the one thing that we struggled on was in section 8.1. If you remember that, it was finding the rule for what would create this sequence, right? And you would start where a sub n is equal to something. And if you remember, we said that in a fraction, we were trying to see what was the rule, right? What's the rule going on? Well, traditionally, we would say that n is equal to 1. We start n equal to 1. And as we plug 1 in, we get out 2/3. We plug in 2, we get out 2 squared over 9, 3, and so on and so forth to infinity and beyond. Well, as we do that, we notice that the 2 on the top, we're going to find 2 rules, mainly because we recognize that the top is 2 squared, 2 to the third. Well, this means that this is 2 to the nth power, and we can check that by plugging 1 in, then plugging 2 in for the second term, then 3, and then 4, and so on and so forth. And we recognize that, in fact, we are correct, okay? Now, look at the bottom, 3, 9, 27, and 81. We recognize that this is multiplied by 3 from the first term to the second to the third to the fourth. So since we are continually multiplying by 3, just be careful. Don't put 3n. That if you put that, you could always double check it and say, oh, well, if I plugged in 1, I get 3. Plug in 2, I get 6. 3, I get 9. Well, we recognize that this is more of a arithmetic sequence when we do 3n in this context, right? So it should make sense because the nth term would be something to a power. So it's actually 3 to the n power. So you could either put it this way, or you could actually put it, because they're both to the same power, which is n, you could make 2/3 to the n power and leave it as that. Now, this right here, probably at least half of you would get this, okay? This one's not a very difficult one. The one up on top, if you notice, this is adding by 8 each time. And when I add by 8 each time, this is an arithmetic sequence. And when it's arithmetic, we would be using our nth term sequence to find that formula. So And I would challenge you to do that and double check it on the review sheet. But the question on the test kind of tweaks this a little bit, and that's why I want to make sure I say this. What if I said, now take it and put it into a summation notation? So simply, we are going to use this rule that creates this, that if I were to add all of these values together, how would it produce, what would be something in a summation notation that would show the sum? Well, first off, summation notation starts here. The fact that n equals 1, traditionally that's what we start with, n equals 1 there. Now the dot, dot, dot tells me that it will continue to go to infinity. It will not stop. It didn't tell me how many terms I have. So it's just going to keep going to infinity and beyond. The next part I do is the what I found for the rule that corresponds to the first, second, third, fourth term, and so on and so forth. We then put after this summation notation to get 2/3 to the n power. And that right there would be how I would write this in summation notation. Now, what if I did that for number 14? Again, I'm not actually finding the sum on 14. All I am doing is writing. It does say only write a rule, but on the test, it actually says take it a step further to write the summation notation of it. So what would that look like? Well, again, we start with n equals 1. Since the fact that this goes dot, dot, dot to the right, it doesn't stop, we would then say infinity is what we would stop at. Then since we said that this is arithmetic where we add by 8 each time, that makes our difference, or our d, plus 8. Therefore, we can use our nth term of plus n minus 1 times d to find what that equation would be. So a sub 1 is 13 plus n minus 1. We don't know what n is, but that's okay. Remember, we don't need to know 1 or n because n is what we're plugging in for. Okay, so just remember that n is what we plug in for. So we need a variable, and n would be that variable. The difference would be positive 8, and then we're just going to simply multiply 8 times n minus 8. Take 13. 13 minus 8 is 5, and then we say plus 8n. And so this is the equation. We can always check it by plugging 1 in, get 13, 2 to get 21, and then so on and so forth. But this is the rule, okay? So many of you probably, like I said earlier, you probably recognize that it's arithmetic. You probably know how to find the nth term. I just wanted to make sure that you all had this exposure to how to put it in summation notation. Many of you probably knew that already, but I wanted to make sure that everyone was prepared, and that you actually had some help with that. Okay. All right. So with that being said, let's get started. We are going to go through these slowly but surely. I will tell you that as we go through these, that there are going to be questions. Some I'll be able to address tonight. In fact, I'll try to address all of them. If you put it in the chat, I'll be able to put that on the top queue. Some of them I might not get to today, and in that situation, coming in the morning, and we'll look at those together, and go from there. Okay. Ooh, yeah, Deanna, great question. So Deanna had asked this. So basically, she had noticed on this problem here. So I'll tell you what the answer was on this one, so you don't have to go back. So this was n equals 1 to infinity, and then I said 2/3 to the n, right? Now, this is correct. However, what you could do, if you wanted to, if you recognize that this, in fact, was geometric, the fact that we would multiply by 2 on the top and 3 on the bottom, making our ratio r equal to 2/3. So meaning like each time from 1 to 2 to 3, it's multiplying by 2/3. We recognize that a1 is positive 2/3 too, because that's the first term, right? What we could do here is if we see that it's geometric, we could actually, instead of plugging this in, which this is correct still, we could still plug in our formula for our geometric. So a1 would be 2/3. R would be 2/3, and then we take it to the n minus 1. The reason why this is okay is because this has a power of 1, and if I were to combine these together, the 1 and -1 exponents, we add the exponents, they would cancel, giving me the power of n. So this actually would be the same thing, even though it looks different, it would be the same thing as what I put up here. So Deanna, that's a really good question. One in which you could put both answers on to get that correct. I hope that helped you there. But that is a very, very, very good question. And again, hopefully cleared that up there. All right. Let's again start by going to the big thing I want to do here is just as I go through is try to address what type of formulas go with which problems. The beauty of this test is that sometimes I actually give it to you. Sometimes it's pretty cut and dry which ones we're using. For instance, we look at one, and again, I'm going to look at all the B versions just because you have the A, but we need the A version. Just let me know, and I can do that too. But it says find the sum of the first 14 terms of the geometric sequence. Well, it gives you two things, geometric and sum. And the fact that it's 14 terms tells me that this thing is going to be and again, remember, this is two worlds, right? Sorry, let me do that again. This is two worlds, right? You have geometric on the bottom with arithmetic on the top. And so when we think of the sum of a finite sequence, we're going to look at that formula here. So in doing so, we're going to say this S of n equals, and I'm just going to plug in my formula here, r to the n over 1 minus r. Perfect. A sub 1 is 3 because it's given to us, so we plug that in. 0.3 is my r. When I plug this in, notice I'm putting this in parentheses because a lot of times people will mess this up and put the negative with it. Remember, the exponent goes first, okay? N is 14 because that's the amount of terms we have. And then on the bottom, we have 1 minus 0.3. So if I were to execute this here as I have this calculator pulled up, I have to make sure that 0.3, when I plug it is in parentheses. Now, since it's positive, it won't matter as much, but just in case, we want to make sure that this negative does not go with that 0.3. So we want to make sure we check that. So let's do this. Let's do this here. All right. I think it is here. Okay. Hold on real quick. I want to make sure. Where are you? There it is. Okay. I know you're not, well, I wonder if it's worth just seeing. I think so many people struggle on this that I think this might be worth worth seeing here. Let's see if we can maybe. Hold on just a second. I would like to just show you how this is done, mainly because I do think that this is probably one thing that on the calculator I want to make sure we hit on. And since you're on the calculator, I'll probably show you something else too, as far as how to do the C. Hello, y'all. All right, let's see here. Not this, I'm sorry. There we are. Okay, so remember that in parentheses, we're going to put 0.3. Make sure you close it both sides. And I remember, take it step by step. So this is going to be to the 14th power. Press enter. Then I will do 1 minus, make sure not to round this too much. So we're going to go second, negative, which is your answer. We're then going to multiply this by 3. And then we're going to divide this by parenthesis 1 minus parenthesis. This doesn't really matter as much with that parenthesis, but just so you know, R goes in. 1 minus 0.3, or you could just put 0.7 if you could see that. But as I do that, I notice that it's 4.29. Remember, the 5 is what bumps up that 8 to 9. So we get 4.29 as that answer there. Cool. All right. And that would be my sum. That's how we would do it. Remember, too, the C, I'm going to show this once, and that way we don't have to come back to it. We'd go to the math button right here. We'll go over to probability and look at the NCR. Now, for many of your calculators, let's say I was doing 8 NCR 5. We're going to put 8 in first. Then I'm going to go to math and then go to probability. Go down to NCR, put the 5 in, and there you are. It'd be 56. So that's, again, just another way that you would make sure that you would need to know on your calculator the 8C5. Very, very important for tomorrow's test. Cool. All right. Let's see here. All right, let's see. We've got this, and we'll come back here. So hopefully that helps with a bunch of different ones, but that does definitely address that specific one right there, okay? See if there's any other questions here. Again, if you have any other questions, throw them in the chat. You could also email me as well. Any of those work, so please feel free to do so. Thanks for those that are showing up, and just appreciate you. Appreciate you for doing that. All right, so let's go to the next one here. We're going to go to number 2, part B. This one's not as obvious here. On this one, it says find the sum of the first 7 terms, but hopefully it makes sense after today's part, because as we look at this here, it says find the sum. Okay, so we're finding the sum of 7 terms. So this is finite because it's not to infinity. And we notice that there's a number, another number in parentheses, to a power. Well, automatically that should give it away that in this situation, this is the geometric form for the nth term. Okay, so we got to recognize that. To where 4 is equal to A1 and negative 2/3 is equal to R. Because remember, the formula is A1 times R to the n minus 1 power. So now once I get this here, we can know that it's the sum of the 7 terms. We can then say, okay, S of n equals A sub 1 times 1 minus R in parentheses to the n, all divided by 1 minus R. So if I were to plug this in, 4 would be A sub 1, 1 minus, here's where we want to be careful, parentheses, negative 2/3 to the n power. In this case, 7 is n. And then all divided by 1 minus, parentheses, negative 2/3. So because of this, please do not, right here and here, do not make that positive, because you got to do the negative 2/3 to the 7th first. Do 1 minus that, multiply by 4, and then divide by the bottom. Notice the bottom, I could actually make this positive because of the fact that there's no exponent here. But once there's an exponent, you got to do this first prior to making it positive there. Okay? All right. Let's go to the next one, number 3. Hopefully we're just kind of hopping all around, I know. This one states that we're talking about recursive, which just is a fancy way of saying if I plug in A1, the value that I get out for A sub k plus 1, which would be here, would be this next term. So basically we're taking 3, we're then subtracting 2/3 to get 2 1/3, which produces my A2. To get the next term, I do 2 1/3 minus 2/3 to get the third term, and then so on and so forth. So finding the nth term of the sequence, we recognize that in this example, the when I subtract by 2/3, I know that it will be the nth term of my arithmetic. So A sub 1 plus n minus 1 times D. Because we're finding the nth term, that means n is not known. And that's okay. So we're going to leave the n here and the n here. The A sub 1 was 3 plus n minus 1. And the D was negative 2/3. That's what's being subtracted each time. Okay. Now, the tough part is probably just the algebra part, because at this point, you're now just solving to say, okay, negative 2/3 times n is, and I'll put it over here, negative 2/3 n and plus 2/3. And then we had a 3 on the outside. This is equal to A sub n. So 3 plus 2/3 is 3 2/3. So A sub n equals 3 2/3 minus 2/3 n. And you could also put this as 3 times 3 is 9, plus 2 is 11. You could put this as an improper fraction as 11/3 as well. Okay? Awesome. Number 4, let me do this. Let me make sure I don't have any questions. Questions. All right. I want you right now, just like Dora the Explorer, if you were watching it, if you watched that show, I want you to yell at the screen. What would you do at number 4? If I said find the first 8 terms of this sequence, what would you do? That's exactly right. I hear you, Ryan. Hopefully you're listening. In this instance, if I find the first 8 terms, I plug 1 in for n. Now, you could possibly plug this in your calculator by going to y1 and plugging in n squared minus n to the third, and then going to second graph. In that instance, it will actually get these out for you. So you could do it that way. You could also plug 1 in. 1 squared is 1, minus 1 to the third is 1, and 1 minus 1 is 0. So a sub 1 would be equal to 0. A sub 2, if plugged in, would be 4 minus 8, which would be negative 4. The third term would be 3 squared is 9 minus 27 is negative 18. The fourth term is 16 minus 64, which should be 48, negative 48. And you would keep going and going and going until the 8 terms were the ones you found. Now, what if I said find the sum of these 8 terms? If I did that, then I would make sure that I would add a1 all the way to a sub 8 together to get one common term. And that's how I would find the sum of the 8 terms that are there. Cool. But if it doesn't, you would just list it out like I'm doing right here. Okay. All right, number 5. Let's look at this one down below. It says find the 22nd term. Now, notice that if it does not say find the sum, or if it doesn't have a summation symbol in that example, then you are going to find a sub n, use the a sub n formula. And since it said it was for geometric, we simply plug it in like so. Okay. So it says find the 22nd term of the geometric sequence. Okay. Hold on just a second. Try to get a little comfortable on the floor here. Like to spread out just a little bit. There we go. All right. So a sub 1 on this one would be 2. As you can see by the sequence right here, a sub 1, the first term is 2. The r is what I am multiplying by to get to the next term. So 2 times what is negative 6? Well, r would be negative 3. Okay. So what we would do is say 2 times negative 3 to the n minus 1. Okay. So if I said find the nth term, this is what I would be looking for here. But I'm not. I said actually find the 22nd term, which just means fancy term of saying I'm finding a sub 22 or the 22nd term here. So we plug in 22 in for n. 22 minus 1 is 21. Make sure you do negative 3 to the 21st first and then multiply by 2. Cool. So do the exponent first and then multiply by 2 to get our right answer. Cool. All righty. Make sure no other questions. Appreciate those of you who are online right now. I really do appreciate all y'all's help. Cool beans. I'm just going to keep continuing. If you have any other questions, hopefully this will make sense here as we continue on these next problems. I think Trey, you had this question. The question was write the first 5 terms of the geometric sequence. So we have 5 terms, 3, 4, and 5, where the 4th term is 15. Now, in a geometric sequence, we recognize that the ratio is positive 1/5, right? It's 1/5. So in this example, if I knew that the 4th term was 15 and I was trying to go to the right, from the 4th term to the 5th term, I would multiply by 1/5 to get to that 5th term. So 15 times 1/5 would be a value of 3, right? Well, if I go 1/5 to the right, if I was going backwards, wouldn't it make sense that instead of multiplying by 1/5, I would multiply by the reciprocal, 5? Well, that's exactly what I'll do. So I'm going to multiply by 5 backwards. And when doing that, I get 75. And when I do that again backwards, I get 375. And when I do that again, I think it's 1875. I'm doing this in my head, but I believe that that's how you would do that there in terms of I know that this is the process, but I believe that you might want to check me on those too. Now, just to double check, if you did it algebraically, you could do this by doing a sub n equals a1 times r to the n minus 1. And let's say I was trying to find the first term because we don't know what that would be here. So if I was finding just a sub, oh, I'm sorry. Let's say we're finding, a sub 1. That's right. And since we know the fourth term, we would say a sub 4, which in this case is 15, is equal to a sub 1 times 1/5, because we know that that's the r. And we know that n was 4, so we put 4 in, and so this is going to be to the third power. So in doing this, we can, in essence, get a1 by itself by dividing. We do 1/5 to the third and divide by 1/5 to the third, which is 1 over 125, okay? And we could flip this to the top by multiplying by the reciprocal, and that's one way, again, that we could get to a1 and then multiply by 1/5 to get to the second, third, fourth, and fifth terms there, okay? On number 7, it says find the sum, there's that word again, of the infinite geometric series. Now, they were kind of nice, but I don't even have to put this infinite word in. The fact that it's ... and there's no set number that's being added by tells me that it would be an infinite geometric sequence. So because of that, we have S of n equals a1 over 1 minus r, okay? Now, S of n is the formula. We don't even need S of n. This is the sum of an infinite geometric sequence. So we would say a sub 1 would be -1. Okay. And the r is kind of the tougher part, because when I look at -1 to 2/3, -1 times what is 2/3? Well, I think it would make sense that anything times 1 is itself. So it would be 2/3, but because it goes from negative to positive to negative to positive back and forth, we would make this negative, this ratio negative 2/3 as well, okay? To go from -1 to positive 2/3. Now, 1 minus negative 2/3, we add this together. We could put a 3 on the bottom to get common denominators. What I do to the bottom, I do to the top. 3/3 plus 2/3 is 5/3. -1 divided by 5/3, I could flip this to the top, make it 3/5. -1 times 3/5 would be equal to -3/5. And that right there would be the sum of a infinite geometric series. Okay. By the way, I know I am going quick through these. If there are any other questions, come on, stop me, whatever you need to do there. At this point, I know I'm the only one that's on here, so I'm just trying to get through as many as I can so that those that, when you go home tonight, you're able to see that there. This one, find the 23rd term of the geometric series. You could check that one out. Just to give you a quick heads up, we did this one earlier, but this would be a sub 23 equals a1's 3, r is square root of 3, into the n minus 1. Well, that would be 23 minus 1. So you would do square root of 3 in parentheses to the 22nd, then multiply by 3 afterwards. So do this part first, okay? All right. Remember, too, I did say this in class, but just in case, this should be to the 8th power. This should be to the 6th. This is probably the second, I would say probably one of the tougher problems, other than maybe the expanding problems that are there. I'm going to do this. I'm going to do numbers 10, 9, and 10 here, and then we'll go from there. But when you see x squared y to the 4th, you note that the equation for this would be NCR and x to the n minus r and y to the r. So a couple things we need to note. We know NCR is a specific value, right? But n and r are very important in determining what those are. Well, n is always the largest exponent the binomial is taken to, or the power of the binomial. So over here is 6, and notice the y to the r power is here. So if you look at this, this is y to the 4th, and in our formula, which will be given tomorrow on that formula sheet, this y to the fourth power is the same as r being positive 4. So in essence, we could just plug this in. So what we would get is 6c4. This right here is the coefficient in our Pascal's triangle, but this is just a quicker way of doing it. This would be x to the 6 minus 4, which would be, again, would make sense that it's 2 because it's stated above, and y to the fourth would be there too. The problem, though, is what is x and what is y? Well, we remember that 3x goes in for the x because it's first, and 2y goes into y because it's second. So we would then get 6c4 and 3x to the second power and 2y to the fourth. So 3 squared, we'd get 9 here. 2 to the fourth would be, oh, and by the way, the squared would go to the x too. So that's x squared here. Okay. 2 to the fourth is 4 times 4, 16. Y to the fourth. Okay. And 6c4, let's make sure. Let's see if we got our calculator. Let's see, we got, so 6, I'm doing this on my calculator. Hopefully this makes sense without seeing it. 6c4, boom. I got 15 for this right here on my calculator. So I would get 15 times 9 times 16. 15 times 9 times 16. I get 2,160. And then that's where I put x squared y to the fourth. And so the coefficient would be 2,160. Remember that this is all one term. So it's not like I am distributing this value to each part, but in fact, we just multiplied the values there, 15 times 9 times 16 to get one specific value. Cool? All right, I minus 3 to the third. Just a heads up, when we expand this, we remember that anything to the power on Pascal's triangle, when I expand, I'm not looking for one term. I'm looking for all of them. So this is 1, 4. Oh, hold on. I want to make sure 1, 3, 1. Oh, yeah, it's 1, 3, 3, 1. My fault. 1, 3, 3, and 1. Okay. Remember the x value is to the highest value, or the value of the exponent of the binomial. So x to the third, x squared, and x. Over on the right side, we get y to the third, y squared, and y. What gets plugged in for x is the first value. So we plug I in for x. So we're going to get 1 times I to the third. Over here would be 3 times I to the second times -3. Okay. Over on the third, we get 3 times I times -3 to the second and 1 times -3 to the third. Now, the biggest problem I've seen or saw today and throughout is this is 1, this is 1, this is 1, and this is 1. You are not distributing 3 to both of these, okay? It acts as 1 because you are multiplying, right? You're not, there's no, if there was an addition symbol here, that would be different. But because they're being multiplied, we simply multiply them together. So I to the third would mean there's 3 i's, one pair being -1. -1 times that remaining I is I. So negative I is actually my first part of my first term, or my simplified part of the first term. I squared is -1, so we'll plug that in. 3 times -1 is -3. -3 times -3 is +9. Okay, so we keep that there. -3 squared is +9. So we have 9 times I times 3, which would be 27I. Okay. -3 to the third is -27. Okay. And so -27 plus 9 is -18. And 27I minus I is +26I. Traditionally, the I follows the second part to be complex. We have our real number plus our imaginary number, and there we go. All right. Yes, I want to do one of these. Let's see here. What time are we doing? How we're doing on time here. How are we doing on time? Let's see how we're doing. Good. All Let's see how many people I've got on my podcast. Me, I am on my podcast. This is very discouraging. I'm joking. I'm messing. Couple things I want to make sure I do go over. We did go over 11A here. 12 we are good on because this is a calculator one. We went through number 14 already. Infinite, we've already hit on. Just make sure on this one, infinite geometric. A1 is -8. The R would be, the top doesn't change. We just multiply top by 1, bottom by 3, right? So 1/3. And so just know how to plug that in the formula. Find the first 5 terms of this sequence. Would be pretty simple because I would plug 1 in for n. And the big thing is just make sure you simplify. So if I went here, that would be 2 times 1 plus 3. Make sure you do exponents first. So -2 to the first in parentheses is -2. And then this would be 2 times 1 is 2. 2 plus 3 is 5. Okay. So technically you could work inside the parentheses first and then the exponent, but it wouldn't make a difference. 2 times or -2 times 5 is -10. So that would be the first term, and you would just find the first 5 terms of that. Expanding, we've kind of done that pretty good today and in through, well, I just did one there. The big thing with X and Y is making sure you do one step at a time. I can do that in class tomorrow morning before school. So if you need some help, come on by. B part is the 10th term, meaning we're going to plug 10 in for n. Again, just make sure that you do it step by step and you do PEMDAS, and you should be good to go there. Yeah, I want to do number 18. I'll come back to that one. 19, we pretty much have already done that. Make sure when I plug -2i in that when I take it to a power, we take the power to the -2 and the I, which, again, we've done already. We've already done that one. And these two as well are ones that are very, very good, okay? So I would like to go over 4 quick problems, and we will be good to go. In fact, what I might do is we did this one in class. Kind of already did this one in class. If you need some more help on number 11, let me know. But the reason why I'm gonna skip to numbers 20 and 22 is because both of these involve arithmetic sequences as well. All right, so this one states this: the sum of what? Now, this is where you tune in, arithmetic series. So remember that when we look at the sum of an arithmetic series, it's got to be finite right here, right? So we plug in our formula before we even read anything else. We have n over 2 times a1 plus a sub n, which is the last term. So the first and then the last. So it says the sum is 240. So a little different because now it's saying that this sum, or the addition of all of the specific values in the sequence, is 240. So we're going to put 240 in for s of n. Now it says if the first term is 10, okay, so this is a sub 1, we could plug in for. So 10 is a sub 1. And there are 12 terms, 12 being n, right? So we got 12 divided by 2. Find the value of the last term. So what is the last term? The last term is a sub n. Well, what could we simplify? Well, we could actually simplify this 12 over 2 to get 6 here. Okay, so we've got this mess. Here's what's cool about this. Because we have one equation with one unknown, we could solve for this unknown, which is the last term, by dividing by 6. 240 divided by 6 is 40. And make that equal to 10 plus a sub n. We then could subtract 10 on both sides, and we get 30 is equal to a sub n, which is the last term in this sequence. Okay. You would do the same thing on this one, except s of n is 120. First term is 6, and there are 12 terms. Okay. All righty. Let's go to the next one. This one here. Okay. Anytime there's like a word problem, I always like to draw it out. It just helps me. Each row in a small auditorium has 2 more seats than the preceding row. Find the seating capacity. If the auditorium has a front row seating 15 people, so here we are, 15. The second row, 2 more, right? So 17. Third row, Again, 2 more. This would be 19, okay? The 21, 23, and so on and so forth, okay? It says find the seating capacity if the front row seats 15 people and there are 30 rows. Well, 30 rows means there's 30 different values in our sequence. So we're summing up, and because we're adding by 2 each time, 15, 17, 19, 21, 23, our difference is 2. We may need to come back to that, but more importantly, we know that it's arithmetic again. So a sub 1 plus a sub n. Now, because there's 30 rows, we could say that we're trying to find the sum of 30 rows that equals 30 over 2 times a1, which a1 would be 15, plus a sub 30, okay, which would be the 30th term. Okay, so the question is what is the sum, but really more importantly, before we find the sum, is what is the 30th term? Well, when we hear what is the 30th term, a sub 30, we go straight to our nth term formula, which would be a sub n, or in this case, a sub 30. I'll put this down here, okay? A sub 30 is equal to a sub 1 plus n minus 1 times our difference. So what is a sub 1? That is 15 plus 30 minus 1, which is 29, times our difference, which was 2, okay? We got our 30th term equals 15, or 29 times 2, which would be 58 plus 15, which would equal 73, okay? So 73 is what goes in for the 30th term. So we've got 88 times 15. And when I do that, once I plug it in, it's 15. That equals 1320. Cool. This is equal to 1320. 1,320 seats. Good job, y'all. Y'all rock. Great work there. Oh, I did forget one other question, and I do want to make sure that I have not forgotten anyone. I want to make sure that there's still, if there are any questions, we're good on that. Perfect. Yes, which one was that? Oh, 18. Find a formula for the nth term of the sequence, just in case. Yes. Okay, 4. Oh, yeah. Go. I'm trying to look for a hard one. 2. Okay, so the top term up here, this is finding the formula for the nth term. Remember that in the bottom specifically, we have 2 different types, right? We have the bottom, which we multiply by 4 each time. And if I did that, you could, because we multiply by 4 each time, on the bottom, you could use your formula a sub 1 times r to the n minus 1, and that would get you the correct answer. But like the one I did at the beginning, you could also do it just simply by just trying to do it in your head by saying, okay, if I did 4 to the n power, it begins with 1. I have to subtract 1 to push it back left 1. It probably is easier if you are able to see that this is geometric to plug this in, where A1 would be 1 and 4 would be our R. And then we just make it to the n minus 1 power. Now on the top side, we see that we're adding by 2 each time, which means that it's an arithmetic sequence, which means that we could just do the A1 plus n minus 1 times D. Now we might have to simplify it because A1 is 2 plus n minus 1 times 2 because we add by 2 each time. We multiply by 2 to get 2n minus 2. The 2's cancel out to get me just 2n. So you could say 2n over 1 times 4 to the n minus 1 power. And really, you don't even need that 1. And that's how you come up with that sequence. On the top side, notice you're multiplying by 3. I would use this geometric formula on the top. On the bottom, because we're multiplying, if you see this 1, 1, or you see we multiply by 1, then multiply by 2, then multiply by 3. Remember the formula of the factorial, n factorial. This means that if I were to plug in 1, I would get 1. Plug in 2, I'd get 2, plug in 3. 3 factorial, if you remember, is 3 times 2 times 1, which is 6, right? Which would get here. So because of that, remember 0 factorial is 1, 2. So we want to push this back left because we have 1, 2, and 6. So they're really the correct answers, n minus 1 factorial there. If I did just the bottom, okay? So again, if you need some more help on these, this is stuff that we could go over in the morning on. I hope this was of help to y'all. Mainly, I know that there's a lot going on. I know that, well, I know that you're feeling it. You're feeling it. You're almost done. But I will tell you that, well, you're the best senior class I've had in terms of really staying focused. So I'm proud of you. Just know that I'm proud of you. Know that I'm here to help you. Know that I know this is difficult, but I hope you feel that I'm in the journey with you. Keep fighting one day at a time, one day at a time. I do love y'all, and come in the morning, get some help, and we'll go through some stuff together. We'll see y'all. Have a great day.